but I've gone, no, I'm going to do this. I remember, not only is it a food stuff, it's a challenge. My God. It's one of the spiciest things I've ever put in my mouth. And I haven't done it for a while. So, it's like torture. It's like it's like flagellation. That's what it's like. But I keep going until the bowl's finished because, you know, it's what I do. And I'm sitting here 10, 15 minutes after the fact, and my lips and my mouth are still burning. And it gave me a high that the beer couldn't even touch. And I wonder why my wife thinks I'm crazy when it comes to eating spicy shit. Anyway, I don't record enough footage of space engineers for YouTube, and I apologize for that. I've got a lot of snot going on as well. Fuck. Just clamping my mouth together and having my tongue touch anything else in my mouth is relatively painful. We're working in Bugly because what we're trying to do, all right, believe it or not, and maybe you know, maybe there's not enough programming on YouTube in space engineers. Maybe there's not. I don't believe I've ever watched a space engineers video on YouTube that contains a hefty amount of programming in it, right? What we're trying to do with Bugly is being able to take them to a designated spot and then have them, like, for instance, like, let me go down here for an example, right? For starters, anyway, you know, like I'm trying to make it as dynamic as possible so you can put in, you know, some arguments into a programmable block and do more things with. But let's say, for example, we start Bugly here. I want to be able to set Bugly off. Bugly will drill forwards for enough time, stop, reset drills, set drills to side deploy, and then drill for X amount of time over to the right. Stop after a designated amount of time, and then repeat. Move forward and drill, and then move left and drill along, and then reach where they were before, and forward again and back. So I want to be able to set Bugly off from this point here to do that, and just leave Bugly alone. And they might do it indeterminately, or they might do it a set amount of times. That's, I guess, phase 50 of Bugly. There's lots of stuff to take into consideration here. I said to some friends of the NID, I said I'm about 70% there and getting Bugly to be able to do this. I'm not really. I'm probably more around 65% there. What we'll do is we'll just unlock Bugly and we'll take off a little bit. I'll show you where we are, right? If we take a look at my toolbar for Bugly, this is toolbar 1, 2, 3, 4, 5, 6. Got nothing in 7, 8, or 9. There's a lot. I've got a lot of things going on. Bugly themselves has a total now of that many timers. That's got to be 1, 2, 3, 4, 5, 6, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. 24 timers. Now, I know I could reduce these timers down with more programmable blocks. Essentially, we could probably reduce these quite a lot. What we've done, I'll show you one thing we've done, right? We need to get Bugley into a certain state, which is that. That's a bit violent. A bit violent there. Why are you doing that? Wait, what did I press for that to happen? Side vertical cycle. I don't know. I don't know what I pressed there. Can you stop doing what you're doing? Can you stop that? Okay, let's watch. 8. Yeah, there we go. Yeah. So one button press, one timer, now takes care of from the drill deployed state. We'll set the right limit, set the drills on, set the drill wiggle, and set the vertical loop, and set into motion side drilling. Okay. Now, if I press 5, no. 4. If I press 4, watch what happens. Turn all this off. 4. We move left and stop. And we wait. And then we'll move left again and stop. So there's this gradual, very gradual move left through 2 timer blocks, which is a big waste of 2 timer blocks, to be absolutely honest. But it's there's thrust override being set with 1 to 90%, and then 0% with another one, and delays obviously in both of those blocks. But what it means is that we can gradually move left and keep on drilling as we go. We don't have to man this. This is all automatic now. Right. So we can stop that moving left by pushing stop on the timer. Timer move left stop. Okay. Where we're at a bit of a sticking point now is block number 6 there. See this one here is a programmable block with vertical stop checks, right? And that's just a straight up normal, oh shit, oh, calm down. Run that. Please ignore the floating corner lights going around in the circle on the left there. That is not real. It's part of your imagination. We now have a programmable block that will stop this side drilling and reset the drill arms to the drill's deployed position, which is straight down. There's a number of things that have to happen there. Well, there's not too many things that have to happen, but it's the state in which they have to happen. We need to do the drill wiggle stop. We need to do the side drill stop, and we need to switch the drills off. And then we also need to do the reverse of the side drill deploy, which puts them back down to the vertical position. Problem with this that I'm trying to solve, which I have solved. There's a further bit here. One of the problems we had to solve is that the stop timers that I currently have, they have to stop. They have to be triggered on a particular state. So, for example, the drill wiggle stop has to be triggered when the rotors are at a negative velocity, or No, when the hinges are negative velocity, sorry, this gets complex. So when the drills are moving in towards each other, like from, out to in, they have to be stopped. That timer has to be triggered when they're moving in towards each other. Otherwise, if you do it the other way around, the drills will stop at an extent, the wrong end of the spectrum for the next state trigger. And the pistons on rotors, they have to be stopped on a negative velocity when the rotors are at negative velocity, which is basically as the pistons are moving bottom to top. So there's no way of doing this with timer block. We have to be able to read the states of the rotors and hinges to decide when we trigger the timer block. And so this is where we're using a programmable block to do this. So where we are at the moment, right? Let's pull it up. I hope everything I've said so far in my spice haze and margarita and spice haze, I hope things have made sense. I do want to bring to the forefront, one of my big things I want to do is bringing the programming and Space News to the forefront. I'm programming in C#. C# is brand new to me. I'm a programmer of 25 years, never programmed in C#. C# is Anubis's language of choice, or the C family, because you've also got C++, which is different. Don't ask me how, because I don't know. C# is a language that will compile down to a how do we say it? A lower level language, like machine code or assembly. I'm pulling words out of my past now. And the reason I say that is because I'm more of a front end developer. I program in JavaScript, and it's funny because Anubis, we had a chat about languages, and I'm such a front end developer that I don't care. I don't care. I'm programming in JavaScript. Well, I program in PHP and Ruby and JavaScript and other things, TypeScript. But they're all the kind of same. They all transpile to the higher level. I don't know. I might have lower and higher wrong around there, but they're all front end languages. We're C#, Java. They're more. They're more the lower level languages, the machine level languages. Whatever. They're all the same. They all do the same things. They've all got the same kind of methods. Whatever. So if we go and have a look at what we've got in this particular script to see where we're going wrong, because what we can do with this script, I'll show you what happened. If I press 6 on my hotbar, which will run the programmable block, if I press 6, you'll note nothing seems to happen, right? But if we keep watching, gradually you'll see things start to happen. The drills stop, the drill wiggle stops, and the drills are facing inward, and the piston arms rest at the bottom. So a number of things have happened in that script, which is supposed to happen. But the final thing that's supposed to happen in that script is the drills should reset to the drill deployed position, which is piston arms facing straight down, with also the pistons facing straight down as well. Well, some of those hinges changing. There's a lot going on here. So if we have a look at the programmable block, we can go through a little bit. And this is what we call a bit of rubber ducking. in the industry. Programmers will often hit a point where they go, I don't know what's wrong, there's a bug in my program or an error. Don't quite know what's going on. There's so much going on that it's going to take me a while to step through the whole flow of the code. But we find that if you talk about in English language what you're trying to do in code, or if you talk about what your code is doing or what you think it's doing in your head, going, well that doesn't work, does it? That's a stupid thing I just said. Even when you're talking to a rubber duck. And it came from, I think, some programmer at some point having an inanimate object on their desk and them talking to that inanimate object about what was going on in the code, and just through talking they managed to solve the problem. So I still need to memorize what's going on with Space Engineers C#. So this is all written in C#, programmable blocks in Space Engineers. What kind of C#? If it's a watered down and diluted C#, I'm not entirely sure. There is a bunch of methods in here. One of them is program. Another is main. There's some more that are standard. I think one of them is save is standard, but we don't have that in here. We just have oh, excuse me, conditions. What's that? What we find better in doing programming is certainly not using this interface in Space Engineers because it's shit. Let's just copy all of this. We've got a lot going on here, and we're going to paste it into Sublime Text, right? Sublime Text, it's just a fairly simple coding application, which can highlight your code and colorize your code, make it a bit more readable. So we're splitting. You can see here any line that's got a double forward slash on it is a comment in the line and is not actually read when the code is compiled. These lines are just visual things for the programmer or whoever's going to read the file to go, all right, well, this is, English language kind of thing. You can see here, double slash, how long is it? How long it's been effectively still, blah, blah, blah. You got some English sentences there. But the rest of it that don't have the double slashes, that's actually code that's going to be run when this is compiled. Now, we've got a config section here. We've got we're running what we're doing here, right? Because we are having to do some things when the Bugly is in a certain state. Do we need to park Bugly? Probably do while I talk about this. Otherwise Bugly will run out of power. And it'll be a sad state of affairs. I don't know what I'm doing with my mouse. I generally drive Bugly with my keyboard these days. Now, I am not procuring myself as an expert programmer. I've programmed for many years in a number of different languages, but certainly never C#, okay? So I'm no expert. But only by talking about these things, actually, what we need to do here is go here. We need to do side drill deploy. That will put down our drills at the angle we need. Then if we did drill deploy, that will put our pistons and drill and hinges at the angle it needs to be, to then be able to lock our connectors. Everything's locked and secure. And we can float back down to the connector here. Before we float back down, we'll actually deploy the legs. So they're ready and waiting when we go down. When we get close enough, we can connect that connector, and Ugly is connected. Lovely. Now, back to this. Yeah, I don't usually do things like this. As a coder, I spend a great deal of my time on Google, you know, looking up code. Every language has inbuilt ways of doing things. We call them methods, functions. There's buzzwords like parameters and arguments. They all mean something. But as a programmer, don't be expected to remember everything all the time. It's impossible. If I move to a new language, I go, right, I can use specific constructs that are present in all programming languages to do something. But particular programming languages might have a shortcut or a built-in method that encapsulates. Like, for example, let's make an analogy that we can all understand. If I was to build a car, I'd go, all right, well, okay, we need a car chassis, we need some wheels and axles, we need an engine, we need a steering wheel, we need some doors, blah 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 blah. We need to put them all together like this, like this, like this. What about if there was a blueprint for a car that knew all that already, and I just go get the blueprint and go, we're going to make this? Yeah, that's far easier. Taking a blueprint of something and sticking that blueprint into a machine and going, make this, instead of taking all the parts, individual parts, and putting them together yourself. That's very much like programming. Programming, sometimes you want to make it, you know, rebuild the wheel, but you don't need to, because programming languages have ways to build the wheel already built in. You just need to know what they are. And that's one of the biggest things with programming, is that you might sit down and work on a problem and go, right, I can see a route to this problem. I can see a process that will solve this problem, and you write it all out. You spend ages, you know, writing very kind of base level code using if conditionals and if else expressions and loops and all the rest of it, and go, all right, that's what I wanted to do. And then suddenly later you find out, one of your mates goes, wait, no, there's a method called do all that in one go, you know, just use that method and put these arguments into the method, and it would have done all that code that you just wrote. It would have done it in 5 seconds. Right, and I go, I didn't know that method existed. Yeah, that's the way coding works. Hope that makes some sense. All right, so we want to run this programmable block over and over, because, as I said to you, there's a couple of things that we need to do when some of the parts on Bugly are doing a certain thing. I need, for example, those piston arms to be going down before I set a timer that stops it where I need it to be stopped. I need those hinges to be moving those drills inwards before I can stop them, so that I'm aware of where those hinges are, so I can then do something else. So we need to run something over a period of a few seconds in a loop that goes every 3 seconds. It goes, are these pieces of Bugly doing what we need them to do now? If they are, then do this. If they're not doing that, then check back again in 3 seconds to see if they're doing where we need them to be to do more. So this is what we're doing. We're checking every 3 seconds, the interval. We're running this kind of code. Then we're setting a number of variables to keep track of a number of things, so that we can plug these variables into the code and go, well, has this happened yet? Yes or no? Or how long has it been since this has happened? Or this, you know, what this recording I've done? Or what is the angle that we've recorded on this, you know, at this given point? Don't ask. This is the constructor. This is what gets run when this whole thing gets. This is the main kind of thing. The first thing that gets run is a constructor of any kind of code. We call it a constructor. Here you can see it's called public program. But there's only one real line there that matters. And it's this runtime update, frequency update. And this has got something to do with the way C# uses timers. I'm not entirely sure. In JavaScript, you'd be using set intervals. You'd be setting so many milliseconds every time that's run. But I know this is great content. I know this is fascinating content. I hope so. This is not the usual stuff I do, and I will have. There'll be programmers are quite outspoken people, and I'm sure a lot of them will be. If I do get any comments, there'll be programmers going, "No, there's a different way you can do this." And I'm sorry. I know there is. It's the same thing with life. There's a billion different ways you can do. You can arrive at the same outcome in life. Coding's the same. Coding is exactly the same. And at the end of the day, as long as your code isn't mega bloated or so unoptimized it makes the whole system just slow down to a halt, as long as what happens in for the user at the front end of the game, of the website, of the application, or piece of software, or whatever, as long as they're happy with the way things are running, doesn't matter what the code's like. All right, that's the main thing. People go, oh wait, but there's ways to do this. There's ways to do this, and there's ways you shouldn't do this. Well, you know, people can be right, people can be wrong. There's a big philosophical conversation about all this. The main method here, this seems to handle the bulk of logic or common sense that needs to run through here. So you can see, I haven't even looked at this. Handle commands from the toolbar. Accumulate time since last run. Time accumulator. Look at time accumulator. That starts up here as a variable of 0, a number of 0. The way that's named hopefully suggests that this will be an ever incrementing number, or accumulator. And what we do here is that every 3 seconds it will go time accumulator plus equals itself plus however many seconds have been since the last run of this, which will be 3. So it'll be basically the first time this runs, it'll be 0 plus 3. Then it'll be 3 plus 3. Then it'll be 6 plus 3. Then 9 plus 3, etc., etc., etc. You know your 3 times table? You know how that works. Only run when enough time has passed. So if time accumulator is less than interval seconds, now if we look at interval seconds, where's that? So if time accumulator is less than interval seconds, don't do anything. That's what this return means here. It just means go back to the loop of what you're doing, or break out of the loop and wait for the next iteration of the loop. So if time accumulator is 6, for example, of time accumulated is less than, yeah, this is a strange one because yeah, work out for yourselves. Some of this stuff gets a bit So this is how much, oh, well, we do need to discuss this, all right? So let's talk about this. This is rubber ducking 101. When we run this script, time accumulator variable is 0. We then come down here and we go time accumulator equals itself plus runtime time since last run total seconds. Now this runtime time since last run, if I just copy that, let's look up, let's go somewhere. This is what we do. Let's show usage of Google on the internet and working out some of the names of the methods in C#. We stick that straight into Google. You can see most of my tabs here are to do with C# or space engineers. We've also got Richard Ayoade in Raps and Matt Berry's 80s synth song One Track Lover from Garth Marenghi's Dark Place. Straight away you can see that runtime dot time since last run dot total seconds is a property actually used in the C# in-game scripting API for game space engineers. So this whole property here, and what we can look at here is it's joined. You've got 3 words joined by dots, right? You've got runtime, which is kind of the parent. There's a hierarchy here, right? Runtime is the top hierarchy, and then just down from that, time since last run, and then just down from that you've got total seconds. All right, it's a property. At the end of the day, runtime is a property. Runtime dot time since last run is a property. Then you got runtime time since last run total seconds is another property. You got parent, child, grandchild. However you want to envision that. Oh, I'm sorry, my protectorate guns killed you. Okay, so let's go in here. We're going to edit the code. This will show you the basic template. We can grab this. Let's grab this. And we'll put it into a new tab here. So this shows the basic part. Oh, shit. No. Oh fuck. Hey. Can someone shoot that dog? Where's the gun that shot the other dog? For fuck's sake. Oh my god. What's wrong with the guns? Where's the dog? Come over here. What are you doing? We've discovered there's a problem. There's a dog stuck. Right, I'll just hover above it then. Do the terrible thing. Oh fuck. I've just dismantled 2 things. Sorry, this is interrupted today's coding exercise. Okay. So we get 3 parts. Public. That is a specific thing you can set for letting other parts of an application access code. Like this is one file. This is all in one file, right? This code that's happening here. Putting in public means that other parts outside of this file can access these bits of code. If you didn't want other outside things accessing this code, you'd put these as private, okay? Void, I can't remember what void does. Can't remember. But let's go through it. Public program. The constructor called only once every session and always before any other method is called. Use it to initialize your script. So this is the thing that when your script runs for the first time, it will run any code that is within this kind of this block within program, and this block is defined by opening a curly bracket and doing a closed curly bracket, right? This symbol is used in a lot of programming languages to designate a block of code, a group of code that is to be kept together. The constructor is optional and can be removed if not needed. It's recommended to set runtime info.update frequency here, which will allow your script to run itself without a timer block. So what this is saying is that this particular property can be set to be able to run this code more than one time, because a timer is used to repeatedly run some instructions, right? So that's where this can be used. And if we go back here, this is where we've got runtime update frequency. That's what we looked up, wasn't it? That's what we looked up. Runtime time since last run total seconds, yeah. That's interesting. Runtime update frequency. So if we look that up in Google, and this particular line this here, self-update system is controlled through the runtime update frequency property. Those of you who are familiar with game logic components should recognize the system because it's actually the same. At any time in your script, including the constructor, you can set runtime update frequency, which will automatically register your script for automatic updates at the times you specify, right? So if we look at this, we specify the property, we set the property at update frequency is none. What does that mean? What the fuck does that mean? Let's see, can we find that in here? We can. Of course, you can also do straight assignment as an example constructor. If you want to completely overwrite the value, for instance, if you want to stop all updating, you can assign runtime update frequency equals update frequency none, which will remove all flags and stop any future updating. So I think what we've done there is that we only run this script when we call it with the parameter start, right? I don't want to get too bogged down in the details here, because there's a lot of, well, you know, there's a lot of overarching stuff. This is how much time has passed since the last step. So let's go. Coming back to here. Accumulate time since last run. Time accumulator is plus one. So set internal state. This gets set when you first start the run. When you first run this programmable block, when you actually hit that thing in your time bar that uses the argument start for run, it sets all these variables to these things. So then time accumulator runs. It is 0 initially. The runtime time since last run total seconds is 0 for the first time this run, so this stays at 0. Only run when enough time has passed. So for the first run, if 0 is less than interval seconds, which is set at 3, then do nothing. Come out of this loop and start again in 3 seconds. right? So then it goes, it runs this again. Forget these parts here. And it goes time accumulator is now 0 plus total seconds that have been since those things started. Now it's 3 seconds. We haven't run this for 3 seconds. So time accumulator becomes 3. Now only run when enough time has passed. So if time accumulator 3 is less than 3, if 3 is less than 3, return. 3 is not less than 3. 3 equals 3. So we bypass this. We move on to the next step now, which we didn't do last time. We set then DT step to the same value as time accumulator, which is 3, right? And then we reset time accumulator to 0. Okay. Now we should run echo is a method, an inbuilt method to a lot of different programming languages that will output whatever text you want output to a debugging area, a logging file. Basically gives the programmer some insight as to the precise machinations of what the program is doing. It enables you at any given point in the program to go, can you spit out what's in your memory right now, what you're thinking about? I want to know exactly what data you are working with here to see if it is what I think you're working with, right? So here we're running step, it's outputting the words running step at, and then within these curly brackets it's using a method called datetime.now. This is a property, and what that is, it's looking at your computers, it's looking at the time clock in your computer, and it's going to print it out in hours, minutes, and seconds. This will say running step at 21:19:33. All right. Right. So now we've got. Oh my goodness, there's a lot going on here. Fucking hell. I didn't think I'd get as in depth as this. It's time. 12 o'clock. Kidding. Now we are at something called run step bracket D step DT step close bracket, right? This here run step is actually a custom set of instructions that we've written. Once again, we've written run step is the name of the instruction. In the brackets is information that we're passing through to this instruction. Here you can see if we come up to run step. Remember we said we had this thing called DT step, and we made DT step equal to time accumulator. So we made DT step, for instance, in this loop, we made it equal to 3. We said, all right, let's make DT step equal to the same as time accumulator. They're both 3. Okay. And then when we go run step, we go, right, we want to run a set of instructions whose name is run step and pass it through this piece of information, which is 3, right? It's called DT step, but its value is 3. And when we come to DT run step, we're passing it 3. All right, so what does run step do? Well, it does a fuck ton of things, right? Firstly, it's going to echo out time passed DT6. Right, let's look at this, right? F. let's try to illustrate some of what we've been doing here, right? I jump into here and we go elevate ourselves, because some of this we need to deploy drills. Let's deploy our drills. Fantastic. And we need to set a few things into. I think the best thing to do is be able to hit number 8 here, which starts the whole side vertical cycle, which I'm really, really proud of that this does. Why did drill stop? Drill started and then stopped. It's alright. We will actually go and just then physically flip the switch for drills. I don't know why they stopped. That will need to be investigated. Slip down. I look like a bit of a troll. Right. So we have our whole side vertical cycle running at the moment. If I go into the control panel and go programmable blocks and look at vertical stop check and go to edit, you can see that this is the same set of code that we've been talking about in my other program here, right? Command handling, right? Wow, handle command. Where's that? Interesting. Right, we'll not go into that right now, but that's part of how there's 2 arguments you can give here. You can run your. I can press this button and it will start running all the script. But it will pass this particular argument through. It will, much like in, where is it? Here, when we trigger the set of instructions called run step, or method called run step, we pass it through this variable here. Now, a variable is basically something that can store a value. Value can be anything. It can be a word, number. It can be a true or false. It can be a number, a date, a time, whatever. When we click run here, we are basically running. Let's just say, for simple sake, we're setting off a set of instructions called run, and we're passing through the argument to it called stop here, or start, or whatever we want to type into here. You can see the code actually there's a little set of instructions here called handle command. If we go down to handle command, which is here, you can see it's receiving a bit of data, a bit of information that you've passed to it. And when we say run this set of instructions with this bit of data we've passed to it. If we pass the word start through to it, because you can see this is called argument here. It's expecting a string, which is basically a bunch of text, another word for a bunch of text. If argument equals start, then do these things. And basically what that does is, it does, yeah, right, okay, 10 seconds, we only act every interval seconds, right, okay. 10. That's interesting. Interval seconds is there, 3. Interesting. This sets up, it starts the whole thing running. And it basically using this piece of information here, interval seconds, yeah. And you should get an output. You should actually get an output that says started interval 3 seconds, right? So script loaded, use argument to start. So recompile. That just resets the whole thing. Reads the script in case you made any changes to it. We've got the argument start in here, so let's run the argument here and let's see what comes out on this panel here. Run. There you go. Started interval 3 seconds. Running step at 9 seconds. Time passed 3.1666.54 seconds. This is a whole bunch of things that you'll see that look. You can see this counting up. Step 5. Step 6. Let's count. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1. But every step is running every 3 seconds, right? So it's still running. If I put stop in here, press run again, I'm basically executing part of the handle command method with the argument of stop, or passing through the data stop, and it goes, all right, stop by user. We're not going to step through this anymore. But what it does do, when we ran that, it stopped the whole vertical cycle. It stopped the pistons moving up and down. It stopped the drills. It stopped the wiggle of the drill hinges going in and out. So it did most of what it's to do. But what it didn't do was set the pistons and the drills back down to the deployed drills position, which looks like that. I've got a timer block there on a slot 2, which does that. Okay. Now, why didn't it do that? Well, that's the fucking whole question. Why didn't it do that? Let's just go back here. Let's look at some of the code that makes the other things stop, right? This is the run step method or set of instructions. The run step method is called or instantiated. Again, there's different fucking buzzwords in programming. Called, instantiated, these kind of things. Doesn't really matter if you remember the actual definitions of them. But when the code, because pieces of code run sequentially, you know, line after line after line after line, right? For the most part. So we've got this instruction run step with some data to be passed to it, which is D step, which is at one point in our lives was 3 seconds. Could have been 6 seconds, could have been 9 seconds. It goes up in threes, right? Let's say it was at 12 seconds. So we're going to want to do all these things that run step says to do. Come down here, run step says to do all this. And this is going to be equal to 12 at this particular cycle of this code. Time passed, then we'll get a little echo out saying time passed 12 seconds. Even though it kind of didn't say that before, but whatever. Then what we do here with this bunch of code is we set a whole bunch of variables. We basically reference particular things in the game by any words we choose. Underscore drilled, drill group, timer wiggle. Now you can read through this. For example, let's look at timer wiggle here. We go, my timer block, which is the type of variable this is. And this all comes from the Space Engineers API. And that's a whole set of instructions about how you can connect what the code that you're writing with specific things into the game. But obviously here, we're wanting to target a timer block in the game. So the syntax we need to use is my timer block. We're going to give it a name called timer wiggle. Like, we can make that anything we want. We can make that big penis. Doesn't matter. That's our label to this particular block in the game. And then you've got this whole thing here. It's a grid terminal system This is an upper level property of the game, and then dot get block with name. Now that's a well written method there. Get block with name. It does what it says in the fucking box. It's going to find in the game that you're playing a block that's got that particular name, and the name we're looking for is timer space dash space drill space wiggle space top, with exactly that upper and lowercase, right? So what this does then is that this phrase here, or string of letters, will now reference the block in the game that is called this. There's a direct connection between this word and that block in the game. Now, then we come back, a whole bunch of other things here. You can see there's rotors, there's hinges, more timers. There's a group of drills here that we're referencing. And what we do is that we go, okay, right. As I said to you, remember I said at the start of this whole thing, we need to be able to do certain things to some of the blocks in the game only when they are moving from top to bottom or left to right or whatever. Well, this is one of those things here. It goes, if any of the rotors that are attached to those pistons for the drills have a negative velocity, so we're moving in a certain direction, and that is, in this case, it'll be from like bottom to top. But if the rotors are moving from the bottom to the top, this particular rotor we're looking at, which is rotor BL, and side drill stopped is false, that means, well, the thing's still moving, we haven't stopped already, then let's set off the timer block with a trigger now action, right? That will actually trigger the timer block in game, right? The timer block's got its own things. We could programmatically write out what that timer block does here and get rid of the timer block if we're not using it for anything else. But not only will we do that, we're going to set an internal variable called side drill stop to be true. Because we set side drill stop up here, it starts as false because we assume the side drill is moving up and down. But once we have triggered timer vertical variable here, apply action trigger now, that will actually set off, trigger the timer side drill stop at the right time, so we can then set the actual variable stop, side drill stop to true. So the code in here knows that that is actually now stopped without having to do any more investigation in game. So there's another if statement here which works for the hinges that are doing the drill wiggle, so we can stop them. And then we will actually output after that. We will output we will output the current states of wiggle stop, side drill stop, and position reset. So it'll say might say false all false straight away. Then it might go true false or whatever. We can just see, all right, okay, well that's happened, and that's happened. Now, we're asking a question here. If the wiggle stop and the side drill stop and the position reset variable is still false, this is a negated conditional check here because of the exclamation mark. If we took away the exclamation mark, that would go, we need wiggle stop to be true and side drill stop to be true and position reset to be true to do any of this stuff within this curly bracket section, right? But I don't want this. I want wiggle stopped and side drill stop to be true, but I still want position reset to be false. We're going to negate that, and that's done by using an exclamation mark, strangely enough. strangely enough. And there's a whole bunch of shit done here because this condition tells us that our pistons are facing down. Our drills are still, right? But we still are waiting for the pistons and the drills to be angled down vertically, right? The drills are still going. So what we're going to do here is we're going to forget some of this. We're going to look at the drill group here, which we've denoted here, the Bugly drills. That's the actual drill group. And it's going to look at all the blocks in that group and the drills, right? Drills here. God, we're getting into some shit here. We made a variable earlier called underscore drills, which is a list of type. How do we say this? I don't know C# well enough, but I think a list in other programming languages is called a dictionary or possibly an array or a set. There's a whole different programming languages use different definitions, you know, different terms for the same thing, which is really annoying. But we made a variable called underscore drills, which represents a list of individual drills. It can be any number of them. In this case, it's 4 drills because bugs get 4 drills. So drill group, it goes get blocks of type drills. It goes, all right, there's a drill, there's a drill, there's a drill. Then it goes for each drill in this group of drills. Let's switch the drill off. So enabled, false, off. So moving or on, then turn to false, off, right? If DT, oh shit, that shouldn't be there anymore, should it? Should it? Yeah, that doesn't match if it's there really. Next thing we do is you set another variable called angle, and it looks at the variable label we've given, rotor. So if we go up here, rotor is a reference to drill rotor BL, which is one of the 4 rotors that is controlling the legs of the drills. And it's recording what particular angle it's at this given point in time. It initializes it sets that to last angle, and then there's a whole bunch of maths here that goes, is this angle different to the last angle we recorded in this loop? Is it different? Is it different angle? Well, if it's a different angle to the last angle we recorded, then it must still be moving, all right? Because if it wasn't a different angle, if it was the same angle, then it must have stopped moving. This might be actually what we need here. This is the part here that for me, oh, that's a bit much. A little bit of this in there. We'll just calm that down a bit. A little bit, just a little bit. Can't be here forever. I'm already late, but I am enjoying this. What this is doing here, and again, I take this with a pinch of salt because I do not know C#. We have just set last angle equals float, not a number. Wow, what is that? I mean, what are you doing there? What's the conceptualism of this? What does he mean? come down here. Let's have a look. See that actually converts to what it means. I can describe this now. Key characteristics of float.nan. You really want to hear this? Purpose. It signifies an undefined or unrepresentable result from a floating point operation. Examples including dividing 0 by 0, or taking the square root of a negative number, or performing other mathematically undefined operations. So what this is kind of doing is it's setting a context for what this variable will represent. This variable is going to be a floating number. We don't know what it is. We don't know what it is currently. Is that right? Am I right? Is this right when we're saying float? Last angle underscore last angle equals float dot not a number. Because at the moment it's not a number, but it can be set as a data type float at some point in the future. But we're just setting a kind of placeholder at the moment, all right? That it's a float, but we don't have a real number. It's just a conceptualization of a number, you know, right? That's the shit sometimes when you look at it this closely. So what we do here, oops, wrong thing. What the hell? What the hell? What we do here, this goes, is this a number? All right, yeah. So this is float is not a number. But what this is saying is last underscore last angle not a number? Well, you know what? It is not a number because we set it as not a number up here. And if that's true, I'm trying to decide why that. What I'm trying to just understand why that's required here. So if this is true, which it is, and will always be, unless you set that as something else, then do this. Set underscore last angle as an angle, right? Oh, there we go. Forget everything I just said. We actually then take last angle. So what this is saying here, now I understand. This is saying here, if last angle is not been set as an actual number, then set it as the angle of the rotor that we just took here. Yeah? And that will happen only for the first time. And then we'll actually get an output to the logging area that we can look at going, oh, we've done it. We've initialized the rotor angle. We've taken the first angle of the rotor of this loop. Then we're going to go, this is interesting. Another variable called delta here. We're going to make that the current angle of the rotor on this whatever loop or step through of this code we're doing, minus the previous angle that we have stored in memory. And that could be anything, you know, after 3 seconds has passed, depending on the speed of the velocity of the rotor, it could be like, I don't know, 60 last time, and now it's 35, right? So if we go, it's 35 minus 60, that means you're gonna get minus 25. Right? 35 minus 60. Have I lost it? Minus 25. That's right. So delta is minus 35, right? Oh, here we go. Here's some math stuff. I cannot even be bothered. Can't. I'm not in a state to go, right? That's what this means. Delta is greater than math pi. That was good noise. Let's bypass this math stuff, right? And go, what's it trying to work out here? Well, it's trying to work out the speed that the rotor's going at the moment by giving it a current angle and a previous angle over the time that's passed. There's a fucking formula in there. I don't know what it is, but whatever it is, and there it is. It's the fucking math.abs delta divided by the time passed. Gives us the radians per second. Okay? Go back to your physics lessons, ladies and gentlemen. That gives us the speed. Right. Now, then there's a comparison between the current speed of the rotor and is it less than this variable that's called speed epsilon? If we go up, right back up here and we go look at speed epsilon. Wow, speed epsilon is a small number, 0.01. So I think what we're looking for here really is a comparison where angular speed is 0, because it's not, 0 is not a lot less than 0.01, right? So we're looking to see the point at which angular speed is 0. That really means, if we simplify this, it means last angle recorded was 0, current angle recorded is 0, and 0 minus 0 is 0, essentially, or the difference in that. So the angular speed then is 0. I know it's not that simple, but that's kind of the simplification of it. So 0 is less than 0.01. So still time is plus the current time passed, which could be anything above 0, most likely. Let's say it's 18 divisible by 3. So still time is 18, right? So we echo out, that means we then print out to the screen in the game, still time equals 18. Now, still time. We've said that's 18, right? What's the still threshold in seconds? Now this sounds like another variable that we've set up here. Still threshold in seconds is 2. Consider stop after 2 seconds with no motion, right? 18 is definitely bigger than 2, right? That means here 18 is greater than or equal to 2. Well, that's true, isn't it? So rotor stop is, which is a boolean, and a boolean variable data type. A boolean data type is one of 2 states. It's a 0 or a 1, or a false or a true. Or a boolean is. It's only can have 2 states, 0 or 1. False, true. So is still time is 18 greater or equal than 2? Yes, it is. So let's set this to true or 1. True. Then we check if this is an implicit check of a boolean, by the way. We could go a very explicit check here. We could go is if rotor stop equals true, and that means the same thing. That's an explicit check of rotor stopped. We are comparing, is rotor stop true? Is true equal to true? Yes. Or we can just go if true. An implicit check of rotor stopped. Rotor stop does it equal true? Then we will print out rotor has stopped. And then we will trigger, we'll trigger the timer, timer side deploy, which we have given reference to a variable here, timer, and we've given the actual name of the timer to that. We'll trigger that timer, trigger now, or we'll apply an action to that timer of trigger now. And we'll actually set the position reset variable to true. So this will move. It will trigger the side drill deploy again, which we did manually just back there. And that will move the drills back down. Then we can set. Well, we've now reset the position of the drills. Now, check conditions. What this does is, if we search, this is an instruction group we've made, you know, custom instruction group. Let's have a look where it's referenced up here. After doing the step, check whether we are done. Right. So this is the whatever step. We said it was 18 seconds, so that was the 6th step of this code, for example, is 18 divided by 3 equals 6. On the 6th step, if check conditions. So what we're doing here, it's going if, and it's taking this method here as a kind of conditional check. So it's going, is this true? Is check conditions true? Is the group or method of check conditions, is it true? Let's look at down here what that does. All check conditions does is it will basically give back a variable. Return is basically saying if anything calls this method check conditions, this is what check conditions will say. It will return position reset. Now, if you remember, when everything was successful, when this particular condition was true, it then set this particular variable named to true. So when check conditions is run, it goes, what's position reset say? Well, you know what? It says true. So if true, then echo out to the log, conditions are met, stopping script. Set active to false, and set the frequency of reruns to updates to none. Does that all make sense? There's a lot going on there. And it was really good talking that through, because what I notice there, let's go back to the game, right? Very foggy, the game. We've got 15 minutes of power left. That's okay. Let's set our we're in deploy position right now. Let's set our side vertical cycle on. Go. Right. See, look, watch. Drills are on. Drills are still drilling. That's good. Drills are drilling. Right. That's exactly the way it should be. Still drilling. Still drilling. Yep. Now we've got the drills at the levels it should be. All side vertical drilling is occurring now, and that will just go backwards and forwards forever, right? Now, at any given point now, we could press, if we go G, this here. This runs the programmable block from the toolbar, but we're not going to do it from there. We're going to do it from actually within the control panel, so we can see in here the output. This is where all the echo statements will appear, right? So if we change the argument to start, and run, right, we get this information here. Okay, so we saw it initialize the rotor angle, and then we've got things like true, false, and still time is. So there's a number of things. I can copy this, can't I? Copy that stuff. How much? I don't know how much time we've got left. Whatever. If we go over here, paste what we saw, and if we go, can we split? No, don't do that. Don't go over there. We split. Layout. Columns. There. Beautiful. If we go through the echoes of run step, we'll see. We're in fact, let's start here. Main running step at. There's the time from the date time now property. If we go further down, we've got run step, which has obviously been run at some point, and time passed is 3.166665 blah blah blah, whatever. Let's just, if we could round that up, that's the first 3 seconds, right? Then we're getting true, false. Now, if we're just coming down here, that is these 3 echoes here, and that is the 3 variables where, has wiggle stopped? Yes. Has side roll stopped? Has the movement of the piston stopped? Yes. Has it reset back down to the vertical pistons and drills? False. No, it hasn't. So then if we come down, we did see prior to this particular step, we did see it initialized the rotor angle. Still time is being echoed out here at 0 seconds, right? So what does that mean? Because then we're seeing down here, each step that occurs, we're seeing see this step count here, plus. That's a shortcut way of writing step count equals step count plus 1. So every 3 seconds we see that step count increment another number. Step 6, step 7, step 8, step 9. What we're seeing here is step still time is 0. This could be the problem. So what we're seeing here, we're consistently seeing still time. If we go back to the game, now step 59 here, still time is still 0. But still time being 0 consistently every step of the way, we'll see this increment. Step 63, step 64, and we can see that here every 3 seconds. Running step at 33 or 34. 37, 30, 40. It's not quite 3 seconds. It's just over 3 seconds, but that's okay. We'll forgive the code. But the fact that we're seeing with every step that still time is 0, that means still timer 0 is greater than or equal to still threshold seconds, which is set at 0.01. Well, that'll never be true. So rotor stop will always be false. So if... And that's not true. It's false. So then I'm going to end that there. Because I need to go to bed. I think that's given quite a lot of information. Some of the more studious of you will actually be able to take a look at what's going on and go, well, this is why this is not working. I've actually just parked Bugly because I realised I was about to run out of power in Bugly, and I panicked a little bit, and I parked Bugly and put them back in the garage. So I'm going to leave that there. I'm not going to give the solution. I'll give the solution in another video, whether it be on stream, or I'll probably also allude to it in another YouTube video. I'd hate to leave you hanging. but I hope that's a bit of an insight into programming and space engineers. I'm quite new to it. I'm quite new to scripting in any game. I'm very used to scripting in my normal job for a long time, but C# is also a new language to me as well. So, and I think when it comes to scripting and anything in particular, like space engineers, for example, there's a certain subset of C# that's used, so it might not be everything available, or it just might be a more diluted version of the language itself. So I hope this has helped some of you to understand how it works in the game, and if not, well, you know what? Fuck you. No, no, I don't mean that. I just say that for brevity. Um, Good on you. Ask some questions, put in the comment, and things like that. I wouldn't mind having some discourse over this. Anyway, until next time. Where's my OBS? There it is. Until next time, take care of each other. Bye.